air, ram air. Introduction. The A320 flight deck and cabin environment is controlled by the air conditioning system. The main components of this system are two air conditioning packs, trim air, ram air, recirculation fans, and avionics ventilation. Air conditioning operation is automatic. In addition to supplying fresh air, the system maintains a constant selected temperature that is independently controlled for each of the three zones. The three zones are the cockpit, forward cabin, and aft cabin. The air conditioning system control panel is located on the overhead panel. Indicating lights on the control panel and various ECAM pages provide status information to the crew. Here we show the ECAM Cruise page. It is the normal ECAM display during flight and shows the air conditioning parameters on the lower portion. We will refer to various ECAM pages throughout this training. For now, click the highlighted buttons on the ECAM control panel to view ECAM pages that show reference to air conditioning and pressurization parameters. The packs receive high-pressure air through the pneumatic system from the engine bleed, APU bleed, or a ground source of compressed air. The two packs operate in conjunction with the trim air system to provide independent temperature control for the three zones. The packs provide air temperatures to satisfy the coldest zone selection, while hot trim air is added to the specific zones that require a warmer air temperature. The high-pressure air flows through the two-pack flow control valves to the two packs. From the packs, the conditioned air flows to the mixing unit. The mixing unit mixes the conditioned air from the packs with recirculated air from the cabin that is pulled by the cabin fans. The mixing unit then distributes the air mixture to the three zones. The cabin fans are electrically powered and are installed to recirculate cabin air. By recirculating the cabin airflow is increased and bleed air demand from the engines is reduced, therefore increasing fuel efficiency. The fans are controlled by the cabin fan's push button on the ventilation panel. The normal position of this switch is on. However, the switch can be used to select the fans to off during abnormal conditions, as required by an ECAM procedure. Control for the temperature regulation is provided by the zone controller inputs to the two pack controllers and by the three trim air valves. The pack controllers control the output flow and temperature of air from each pack to maintain the temperature of the coldest zone temperature settings on the cockpit, forward cabin, and aft cabin zone temperature selectors on the air conditioning panel. Trim air is then added and modulated as necessary by the zone controller to add hot air from the respective trim air valves to the air from the mixing unit to maintain the temperature demanded by the respective warmer zone temperature selector settings for the affected zones. The hot air flow to all trim air valves is controlled by the hot air pressure regulator valve that is normally on but can be selected off by the crew or when commanded to close automatically for abnormal conditions. The regulator valve regulates the trim air temperature to meet the requirements for the normal ranges of the zone temperature selectors. External conditioned air. When the aircraft is parked and the packs are not operating, low-pressure conditioned air may be supplied directly to the mixing unit by a ground connection. In this situation, the mixing unit and ductwork are simply used to deliver the conditioned ground air, while the temperature is controlled by the ground-conditioned air source. Ram air. During flight below 10,000 feet, the ram air valve can provide an emergency supply of cabin ventilation during depressurized flight. Ram air is controlled by a guarded push button. When the ram air push button is on and the ditching switch is not selected, outside air can flow through the ram air inlet, through the mixing unit, and on to the cockpit and cabin. If the differential pressure exceeds 1 psi, the check valve will not open to supply ram air flow. When ram air is selected on and the outflow valve is operating under automatic control, the outflow valve will open about 50% as long as the differential pressure is less than 1 psi. When the ram air push button is selected on, a memo of ram air on displays in green. In addition to providing an emergency supply of cabin air after a dual pack failure, the ram air can also be used to ventilate the cabin in the event of cabin smoke. Avionics ventilation introduction. An automatic ventilation system provides cooling for the electronic and electrical components in the flight deck and the avionics compartment. This system is controlled by the Avionic Equipment Ventilation Computer, or AEVC. Avionics ventilation uses external air, conditioned air, or skin heat exchanger air cooling to provide cooling airflow according to a specific configuration. The avionics ventilation configuration is set by valves, a blower fan, and an extract fan. Avionics smoke is detected by the FWS. We'll describe avionics ventilation in a separate CBT module. Battery ventilation. A venturi in the skin of the aircraft draws air from the space around the batteries and vents it overboard. This provides ventilation for the batteries. No control or indication of this system operation is provided to the flight crew. Lavatory and galley ventilation. An extraction fan draws ambient cabin air through the lavatories and galleys and exhausts it near the outflow valve. The extraction fan operates whenever the aircraft has normal electrical power. No control or indication of this system operation is provided to the flight crew. We have now completed the introduction to air conditioning. Now let's answer some questions.